Hey everyone, this is Aurora with Supercharged Science, homeschool science, and the homeschool curriculum for K through 12. And we are doing a free online class in math and science, and it's not just for homeschoolers. So if you are joining me, I decided to come on a little early because we had like 200,000 people writing us emails saying, when is this class? Where is it? So here I am early. And I'm also going just to point out a couple of things. I uploaded some really cool things to the description of this class, including a printout. So if you are the kind that likes to take notes and write things down, go ahead and print that out now. You'll see it in the description for this class. And I can even put it in the comments if you would like me to. Let me do that. So if you want the worksheet that goes with today's class, go ahead and print that out now. It should be the first or second comment in there. And you'll be able to download that and just print it out. So obviously, if you're viewing me from a phone, that's not going to work. You want to print it from something that's connected to a printer, so you can print that out. You don't need it for today's class. If it's too much of a hassle or it's too stressful, don't worry. I'm not going to collect it. This is not a test, but I did create a lesson worksheet for you, and this is the first part. Actually, it's part 2 in a 6-part series. We started with stargazing. In fact, let me show you a slide while we get started here. This is my friend, Pete, and this is his telescope, and he took this picture just a few days ago. This is the Flame and the Horsehead Nebula that are in Orion, and isn't that cool? You can see like a little horse head here. So we did stargazing on Saturday with everyone, and so this is some of the things that we looked at. Actually, we looked at Orion's Belt. I don't know if we looked at the Flame Nebula specifically. It's not a binocular object. You do need a decent-sized telescope to be able to see those things, but they're right around the belt stars. It's the one that's more east. And so anyway, so that's stargazing. That was our part 1. If you missed it, don't worry. You can access our video archives. So if you're viewing Facebook on your computer, you want to go to the left side where it says videos. Just click on that and you'll see all the videos we've been doing. Last week we covered rocketry, we did catapults, we did light, lasers, and holograms, and we did physics, we did energy, we did motion. We did a lot of science. In fact, we had a lot of great feedback from people saying, thank you so much. My kids have done more science in a week with you than they did the entire year of school. So that's great news. And we're going to keep going. So this week, we're going to focus on physics and chemistry, and we're going to do it through the lens of astronomy. We're going to apply those fields into a real field. Now, astronomy is not a big field. There's only about, I want to say about 10,000 astronomers worldwide, about 6,000 of them professional astronomers in the United States alone. So it's not a big field, but it is really important. Those folks really have to know their physics and their chemistry really well. And so we're going to do that today in class. So if you're just joining me, I wanted to say a special welcome to you. There is a worksheet download that goes with this mini science class. We'll be together for maybe 30, 40 minutes. If you want to print it so you can look through it as we go through, you're welcome to do that. It's in the description. It says download the worksheet here. You can download that, print it out, and you'll have it. Or if you just want to wait till after class and use it to see how much your kids have picked up, that's totally fine too. The materials for this class are really simple. If you have some tape and a sheet of paper and a marble. I actually didn't have a marble nearby, but I have a bead, so that is going to work just fine. And I don't know if I mentioned this, but we wanted 2 different size balls. Now, they could be 2 kinds of bouncy balls. They could be a tennis ball and a basketball. It doesn't matter. Just as long as they're 2 different sizes, it'll work. And okay, and so we are getting ready to get started. I know we still have like 2 minutes before the top of the hour. Oh, and if you have a measuring tape, you'll definitely want to get that out, especially if you have one that is inches and centimeters. This is an awesome math lesson for today because you will get to show your kids how to build a solar system, and you'll also get to teach them how to read a measuring tape. Actually, 80% of kids that actually enter an engineering program don't know how to read one of these, which is really sad. There are lots of online worksheets you can download to show them how to read the increments all the way down to 30 seconds and 60/4, or really just to a 1/4 inch or an 1/8 inch is just fine for the US standard system. So I totally encourage this as your math lesson for today. All right, and I'll show you how to do that later. You guys ready to get started? All right, if you are, say, oh yeah. So hello everyone and welcome. My name is Aurora with Supercharged Science, and today we are doing a lesson in astronomy. This is really the first part of actually it's the second part. We started with stargazing a couple of days ago. You can find that in our video archives if you missed it. And so this is going to be the first part. We're going to focus on planetary stuff, and then we're going to move on to objects that are moving in and out of the solar system and in and out, like around the solar system, not completely in a standard circular orbit around the Earth, kind of circular. We're going to be looking at things like comets and asteroids, and also objects that we found recently that are not from our solar system. And so we're going to take a look at that. That's tomorrow. Wednesday, we have a huge class. It is so big that we can't do it on Facebook Live. So it is going to be a class in black holes. So I will show you how you can register for that one. I'll put the form isn't working, otherwise I'd give it to you right now. It should be working by the end of our time today, and then I'll give you that link. Thursday and Friday, we are going to be doing even more. I'm going to show you how to make things. I'm going to make a comet. I'm going to show you how you can measure the speed of light using a bar of chocolate or marshmallows, whatever you have that melts easy. We're going to do a lot of hands-on practical things. So you're going to make a spectrometer. There's a lot of cool things we're going to do. So you ready for this? You ready for our class? Say yes. Okay, so I'm going to be asking you a question. If you can just pretend like I can hear you, we're totally having a conversation. When I ask you a question, you're going to shout back the answers as if we're having a conversation, and we are totally excited to learn about astronomy. So if you're ready, say, oh yeah. Okay, I shared before from stargazing. Here's my friend Pete. This is his telescope, and this is a picture that he took of the Orion Belt. He found a little Horsehead Nebula here. He found the Flame Nebula, and this is one of the big belt stars. Isn't that cool? So astronomy is awesome, and we are going to be studying it right now. And let me get my slides up and ready, and we can get started. Let me grab this. Okay. So a lot of people get really nervous when they talk about astronomy because they feel like it's too big or too complicated, but kids are like fascinated. And one of the reasons I think this happens, same thing with marine biology, people are fascinated. And I think it's because there's a lot of I don't knows in there. We really haven't explored more than 10% of the ocean. We haven't even begun to explore outer space. So there's a lot of, wow, what do you think might be out there? I don't know. So every time we discover something new, then we learn a whole lot more. So I'm going to take you on a tour through the universe. we're going to stay in our solar system right now. And then we're going to go beyond. We also are going to do solar astronomy. I forgot to mention that. And so we're going to learn what happens when stars wander too close to black holes. That'll be on Wednesday. We're going to discover how time travel into the future is possible, and there are really bizarre objects that warp space and freeze time. So you are going to be my flight navigator. Are you ready? Okay, so you're going to tell me where we're going. So I'm going to show you some pictures. So I want you to hop in the spacecraft with me, close the hatch, hit the throttle, and I want you to shout out the answers as you know them. You ready? All right, first stop is the closest planet to the sun. Which one is it? Come on, say it out loud. Now, if you said Mercury, it depends on when in time you said that. Did you know that we used to think there was a planet even closer in than Mercury? We even had a name for it. I kid you not, it was called Vulcan. I'm not kidding. So back in the 1860s, a French scientist published a paper. Now, there's this really weird thing about Mercury's orbit not following the orbit that it should. So people thought, oh, I know what's going on. It kind of does this little wobbly thing around the Earth, around the sun. And so people thought, oh, there's a planet more inner that we can't see, more interior, closer to the sun than Mercury. And it must be yanking on Mercury in its orbit. So let's name it Vulcan. But it turns out that there is no planet. You know, I don't care how good you are. If you look straight at the sun, after a while, you're going to see spots. And that's kind of what happened. Einstein came along and he pointed out, hey, you know what? Your math is wrong. The way you're modeling this is not right. And when they corrected their math and their models, they realized, oh, there is no planet, there's no Vulcan, but there is Mercury. So let's go ahead and get started with our first real planet, Mercury. Did you know that Mercury is a hot rock with not enough gravity to hold on to its tiny little atmosphere? It's the only planet that has a tail. It's the closest planet to the sun, but it's not the hottest planet. Now, how can a planet have a tail? Because it's moving around so fast and it can't hang onto the atmosphere, so the atmosphere kind of streams out behind it. Isn't that weird? Okay, so Which one is the hottest planet? Tell the person next to you. Oh, yeah, I guess I should read what's on the slide, huh? Okay, so Mercury is the side facing the sun gets to 800 degrees. That's hotter than your oven. You would turn your cookies into briquettes. And the side away is almost about minus 300. So that's colder than a freezer. So Mercury is hot and cold at the same time. Okay, so what is the hottest planet? What is it? Tell me now. The hottest planet is, that's right, Venus, but it's not the closest one. So Venus was named for the goddess of beauty, the goddess of love. It's the brightest object in the sky other than the moon. Now, when we named this planet, we didn't know about the sulfuric acid rain clouds, the lethal carbon dioxide atmosphere, the 900-degree surface temperature that melts cannonballs, and atmospheric pressure that crushes any spaceship we send. We didn't know anything about that, which is probably good, or we might have named it something worse. So can you imagine standing in a warm breeze, right? What if that breeze suddenly got icy cold? What would you do? Yeah, you put a coat on, right? So Mars, Earth, and Venus, they're all bathed in a flow of plasma that comes from the sun. It's called solar wind. You can see an image here in the upper right. You see that? So the Earth has a magnetic field, which acts as an invisible coat to protect the Earth because it deflects this wind away from us. Now, solar wind isn't really wind. There's no air in space, so it can't be like the normal kind of wind. But basically, it's a stream of highly charged particles that are coming from the sun. We'll talk more about what those particles are in a little bit. So the blue image here is actually, this is the south pole of Venus. This is taken with a very special UV camera. Venus isn't really blue. It's just the filter on the camera. You know, like if you were to look through lenses that were colored, it makes everything look that color, like rose-colored glasses. That's what happened with this picture. But the scientists use this idea to block certain wavelengths so they can view other ones, so they come out even more pronounced. One of the biggest problems with Venus is it's constantly reshaping itself, constantly getting a new surface because the volcanoes are constantly erupting all the time. So the surface features change a lot, so it's really hard to tell what it looks like. Now here's something weird. One day on Venus is longer than 1 year on Venus. How is that possible? How can a day be longer than a year? I'll give you 15 seconds. Tell me out loud or type it in the little comment box. How can a day be longer than a year? Go ahead. I'll wait. Tell me out loud. What do you think? Okay, so for a day, what has to happen? For a day to happen, you have a planet and it has to rotate once, right? Once on its own axis. Now imagine here, we got the sun here. Here we got the sun. How long will it take for a year? What has to happen for a year? Yeah, it has to go around the sun, right? So it takes Venus longer to do this than it does to do this. Make sense? That's how a day is longer than a year. So Venus goes around the sun once every 225 days, but it takes 243 days to turn once on its own axis. Not only that, it's going the wrong direction. All the other planets go one way, Venus goes the other. Okay, so now let's hop over Earth and we are going to go to the fourth planet. Now, which one is that? Say it out loud. Which one is the planet that's after Earth? Kind of red. Did you say it? That's right. Mars. Now, if we zoomed our spaceship straight to Mars from Earth, it would take about 8 months. The distance traveled is 1.5 AU, astronomical unit. That's how far, an astronomical unit is the distance from the sun to the Earth, so 93 million miles. Okay, so the first 4 planets, Mercury, Earth, Venus, Mars, those are all rocky planets. They're nothing like the next 4. So Mars is basically a rusty burp. It has a lot of iron, a lot of orange color. It has both water ice and dry ice at the poles. It does not have a magnetic field. Remember we just talked about the solar wind thing with the coat? Which means that the sun, when the solar wind hits Mars, it will blast most of the atmosphere that's there, that the tiny little gravity is trying to hold on to. So that means if you landed on Mars, you'd only last 10 seconds without a spacesuit. Now, there have been quite a few missions to Mars. You know, we saw, there's been a number, you can actually see one of them right here, right? So the black and white picture you see in the middle, this is a photograph that was taken. This shows the dune patterns on the floor of a crater, you know, like when you go dune buggy, that kind of thing, sand dunes. So this was taken by the Mars Odyssey that was launched in 2001. Now the blue image in the middle left, so I'm sorry, the middle center here, this one, this is not a crater like it looks like, but it's a volcano that blew itself so hard, it sunk itself. It blew so much material out that the volcano itself sunk, which is the depression that you see here in this image. Okay, you see these two little objects over here? They're kind of blue on the left. They're not really blue, it's just the way the photograph came out. Okay, so these are the two moons of Mars, Phobos and Deimos, which is fear and terror, basically. So these are the real photos of the moons. So you tell me, are these moons nice and round like the Earth's moons, or are they more like potatoes? Yeah, they're more like potatoes, right? Phobos, the smaller one, is slowly spiraling in towards the planet, but it's also orbiting twice as fast around Mars than Mars is rotating. Now, both these things really combine. They stress the core of Phobos out. They put a lot of extra stress on it, which means one of two things in the future is going to happen, is what scientists are thinking. Number one, that Phobos is eventually it's going to shatter. It's not going to be able to hang on anymore because the forces that are pulling on it are so great. And when it shatters, it's either option A, going to turn into a ring around Mars, or B, it's going to create the worst meteor impact ever. So which one do you think it should do? Oh, by the way, nobody knows, and nobody knows when it's going to happen. It's just what scientists are thinking based on the studies and what they know so far. So isn't that wild? Okay, now if you've just joined us, I know with Facebook Live people jump on and off all the time. My name is Aurora. We're doing science. We're doing astronomy, specifically planetary stuff right now. There is a download you can get. It's in the description. And also there is a free, I don't know if I put it in there. There's a free packet. I think I forgot to announce this. Let me put it in the comment section. It's superchargedscience.com/astronomy. Superchargedscience.com/astronomy will get you the astronomy packet that has more lessons in astronomy when we're done. So just write that down, superchargedscience.com/astronomy. Okay. All right. So we were talking about Mars. You ready to move on? Tell me about the next one. Yeah. What's after Mars? Is it a planet or is it something else? Yeah, it's something else. What is it? What is that something else? Quick, say it out loud. It's the Asteroid Belt. That's right. You see the image on the left? That's Ida. Ida is an asteroid in the Asteroid Belt that scientists first found in 1884, but it wasn't until 1993 when the Galileo spacecraft visited Ida and they found this asteroid has a moon that orbits it. It's called Dactyl. You see this tiny little dot here? So the Dactyl goes around Ida. Now, Ida's gravitational field is so weak that if you stood on the surface, you could leap from one end all the way to the other. And actually, if Mom got in here with her car and hit the gas and went faster than 48 miles an hour, she would hit the escape velocity and escape the asteroid entirely. So not very much gravity here. Okay, do you remember what happened to Pluto? Despite how you feel about it, do you remember it was a planet, wasn't a planet? Okay, so the same thing happened about 100 years ago to Ceres. Okay, so see this little ball here on the right? Okay, so Ceres is the largest asteroid in the asteroid belt. And about 100 years ago, scientists thought they discovered another planet and they said, aha, this planet is called Ceres. But it turned out it wasn't a planet because a planet has to have one of three things. And one of those is it has to have cleared out its path around the sun. Ceres didn't do that. It shares an orbit around the sun with thousands of other objects. And to add to the confusion, it was never really cleared up. We're going to talk about this when we get further past Neptune. It's never really been cleared up whether something's a dwarf planet or an asteroid. So for the moment, it's both. So you can see Ceres with a backyard telescope if it's dark enough. Now, this is the spacecraft Dawn. This is the first spacecraft to actually orbit Ceres and take pictures of it. Okay, largest planet time. Everyone shout it out. What's the largest one? Do you know? Tell me out loud. What is it? That's right, Jupiter. Jupiter is bigger than all the other planets combined. If Jupiter was a soccer ball, the Earth would be a marble. So you could open up Jupiter, fit everything else inside, and still have room left over for lunch. And you could fit about 1,300 Earths inside of Jupiter. It takes our spaceship if we start from Earth, about 6 years to travel to Jupiter. Got it? Now, by the way, if you're doing the worksheet download and I'm going way too fast, remember this video is going to be archived in our Facebook archives. And also remember on the last page is the answer key. So in case you missed that, it's behind the vocabulary. So don't worry if I go too fast or you miss something, you can always watch the video again. You can stop me, pause me, rewind me. I can say the same thing over and over as many times as you want. But also there's an answer key. Okay, so let's keep going. Here we go. Now, can you stand on the surface of Jupiter? Yes or no? No. Jupiter is as big as it can be without condensing. What does that mean? That means if you add more stuff, more mass to Jupiter, it would actually get smaller. Okay, but you can't stand on the surface, right? It's a big giant ball of hydrogen and helium and a compressed core of hydrogen. Now, that hydrogen core is so squished that it actually is a different state of hydrogen than scientists are normally used to dealing with. So they call it metallic hydrogen. Basically, it swirls around and gives Jupiter its magnetic field. And when that magnetic field interacts with particles at the poles, Jupiter will produce masers out the poles. Let me break that down for you. Jupiter's magnetic fields are producing lasers out of the magnetic poles, but they're in the microwave part of the spectrum. That's why they're called masers, not lasers. So it's microwave amplification, that kind of thing. And so you need a special detector in order to see them. And it's not like a laser beam. It's more like a dust cloud coming out, but it's a maser cloud, which is super cool. It's not like the green laser beam you'd see come out. It's not concentrated. It's just like a glowing, shimmery cloud. Okay, did you know that planets can make their own sounds? So listen to this. This was recorded by Voyager 1 as it passed by Jupiter in 1979. I want you to listen for 2 whistles that sound like they are falling. You're going to hear a lot of static, like a lot of but what I want you to do is try to listen for those whistles. You ready? Here's an actual recording from the Voyager spacecraft. Did you hear it? Yeah, it was a little hard to hear, right? Okay, so let me play this one for you. And these whistlers are actually found here on Earth. This was found this past decade. Ready? Here we go. Isn't that cool? So what is that? It sounds like, space age ray guns from Star Wars. So they're actually whistlers. They are created by lightning, and basically they move along the magnetic field lines of the planet that go from north to south or south to north. Okay, so they're particles. It's like a linear accelerator around the outside of the Earth, and we actually can pick it up and turn it into something that we can hear. Okay, so how many different moons do you think Jupiter has? Tell the person next to you, tell me out loud, how many moons? Just take a guess, give me a number. How many moons? What do you think? Okay, so Jupiter currently has 67. 4 of them are visible with binoculars, and we are finding more all the time. Now, does Jupiter have rings? Tell me out loud, yes or no? Yeah, yes, but are they like the rings of Saturn? They're not. So the rings are made out of dust that spirals in towards Jupiter. So for example, when something will hit one of these moons, it'll kick up a lot of dust. You ever been like at a playground and you're going down the slide and you get on this and then you hit the sand, right? And there's like this puff of dust. So when that dust when something hits, space rock or something will hit one of these dusty planets, it'll kick up a little puff. And then Jupiter will grab that and swirl it in on itself, and that's what makes the rings. So the rings are constantly being replenished with new material. Now the 4 largest moons are listed here. This is Io, Europa, Ganymede, and Callisto. And you can see them. This is a picture taken through an 8-inch backyard telescope. If you have a pair of binoculars and you're up really early right now, so what month are we in? We're in March 2020, and you get up at like 3 or 4 o'clock in the morning, you'll be able to see Jupiter. If you use your binoculars, you'll see 5 dots all in a row, just like this. This center dot won't be nearly as big, but you'll see 5 dots in a row. 4 of those dots are these moons, and that 5th dot is going to be Jupiter. So it'll be either 3 and 1 or 2 and 2, or if one is passing in front or behind, sometimes you'll just see 2 and 1. So those are constantly changing. And so you can look at that. Now later this year, we're going to have both Saturn and Jupiter up, like later, like fall, winter. And you'll be able to look up and you'll actually see the moons of both Jupiter and Saturn just with binoculars. So that is super cool. Okay, so Jupiter, has one of the coolest moons ever. And you can see this one with binoculars, like I just mentioned. The closest moon is called Io. Now this one rotates 4 times as fast as Jupiter rotates. Remember we talked about Phobos before? This one goes even faster, and it's closer into a larger planet. What does that mean? That means that it has the same thing going on as Phobos did, but the tidal forces are huge, and that's what scientists think is actually driving the volcano activity that I've boxed in here on Io. That's why Io is so volcanic, because it's constantly being squished and squeezed by Jupiter, and because it's just spinning fast. So Io has really active volcanoes. The most impressive part is what these volcanoes can do with themselves. They spew their ash 300 miles high. I mean, that's higher than the space station orbits. So if you parked your spaceship in orbit around this moon, you would need windshield wipers because you would get blasted with ash snow. Now, I don't know of a polite way to say this, so I'm going to apologize in advance. The volcanoes on the moon are so active that the moon is constantly spitting itself inside out over and over and over, and that's why it looks like a giant pizza. Kind of gross, huh? Ew! Now take a look at the half image of Io here. It's actually in phase, so it's not a full phase. It's a half moon phase, half here. There are actually 2 volcano eruptions, and this was photographs that were taken by the Galileo spacecraft. And you see these zoomed in boxes? So this top box is a bluish cloud that rises about 90 miles above the surface here. And the lower box has a ring, and this one is about 50 miles above the surface, so it casts a shadow below, and that's what you're looking at here. What's amazing is that this one has been visible in every image ever taken ever since we first started imaging this thing from 1979 with Voyager. So that means that this volcano has been continuously active for at least 18 years. And when a space mission to Pluto zoomed by, it took a series of pictures that scientists put together into a video. And you can see it here. This is the volcano erupting. So they took a whole bunch of pictures, and we made a video from it. Okay, Saturn, the next one after Jupiter. Oh, I'm sorry, I should have asked you. What's the next one? Saturn. Okay, good. Saturn spins so fast, it's actually not a sphere. It's kind of like an egg. The pretty rings you see are made mostly of ice moving at 75,000 miles an hour, but it is still ice. But it's the moons of Saturn that is where things really get interesting. Can you see the 2 moons in Saturn's rings? Those are 2, Pan and Prometheus. Those of them are shown in the black and white image. There's one here and there's one there. Those are called shepherd moons. They're little white dots that really shouldn't be there in just the rings. They're moons. So this image this is a photograph that was taken by the Cassini spacecraft. And do you want to hear what lightning sounds like on Saturn? Check this out. So this is lightning on Saturn. All right, so Titan is the largest moon of Saturn, and guess what? It has an atmosphere. Not a lot of moons have an atmosphere. Now, this atmosphere is mostly nitrogen, but it's so thick that if you glued wings onto your arms and you flapped and you were on Titan, you would actually fly. So, wait a second. How do you get an atmosphere on a moon? I mean, Mars is a planet and nothing doesn't have an atmosphere, right? What do you think? Tell me out loud, how do you get an atmosphere on a moon? So while you're telling me, I can tell you, we don't know. Whatever your guess is, it's as good as mine. But to date so far, it is one of the most Earth-like worlds that we've found, despite having a giant lake of liquid ethane and methane bigger than Lake Ontario. Okay, so in 2005, the robotic Huygens probe landed on Titan. This is the image you see here. How many moons do you think Saturn has? Tell me out loud, how many moons? Oh, and I'm getting a lot of questions coming in by email too. So while you're telling me how many moons, just to kind of rephrase, my name is Aurora. We're doing a class in astronomy. You didn't miss it. Don't worry if you missed the first part. This video will be archived in the video library. You can download that anytime. There's also a worksheet download. You can do it with this class or after this class. Either one, it's up to you. You can download that and on your own time, and you can take a look at it. It's great to do it after class because then you can see how much your kids have picked up. It also includes vocabulary lists, and there's an answer key in the back. And if you want more, if you like this and you're like, wow, this is amazing, I want more science. Okay, so there's two places to go. There's www.superchargedschool. Let me try this again. I should just write these down. Superchargedscience.com/astronomy. You can download the astronomy lesson packet that I made for you, or you can just access it. There's a bunch of videos and stuff. There's one place. And the second place you can go is our online school, and I'll tell you about that later. It's free. I'll show you where it is at the end of class. Okay, you guys ready? Saturn's moons. Tell me, how many did you have? Okay, well, to date, Saturn has 53 moons. Now, can moons have rings? We think so. In the upper left, do you see Iapetus? So that's the moon that used to have a tiny ring, we think, because scientists see a ridge around the planet, starts around there about the 9 o'clock position. Do you see it? And it swings all the way around the planet. So they're thinking, wait, how can you have a mountain ridge all the way around? Maybe it used to have rings and they crashed in. That's one idea. There are lots of weird moons around Saturn. What do you think about this one? Yeah, where do you think the Death Star came from? Where do you think they got the inspiration? People pronounced it Mimas or Mimas. So that's this one. In the lower left, we have Tethys here. This one has a huge crack most of the way around the planet. You see this really large valley? And Hyperion kind of looks like a rotten potato. And let's see, we already talked about the Death Star here. And the upper one, Dione, is basically a dirty snowball. And Enceladus has tiger stripes and ice geysers. This is the one I'm really interested in. I like this one a lot. Okay, so Saturn and Jupiter are ice giants. Now we're going to move on to two planets. I'm sorry, Saturn and Jupiter are gas giants, G-A-S. Saturn and Jupiter are gas giants. Now we're going to move on to the ice giants. You ready for those? What are the two ice giants? Say them out loud. Okay, let's keep it closer to astronomy than anatomy. Repeat after me. Uranus. I know sometimes it's not a lot better, but try it. Uranus. Okay, Uranus. There we go. So let's see. Let me get this slide. Okay. So the poles of Uranus are tilted so far over that the planet actually rolls around the sun. And because of this, the sun doesn't rise for 21 years on certain parts of Uranus. So it's in an 84-year orbit, and the storms in the planet actually follow the sun, which is really cool. So Uranus and the next planet are both what we call ice giants. And the image on the left, this is an infrared image taken by Hubble so we could see the different cloud decks, the different cloud layers. This is on the right. This is a true color image. This is what you'd really see through an optical telescope with your eyeballs. It's this color because it's made out of really cold methane. And so if you had snake eyes, you would actually be able to see this. So astronomers use different filters so they can see different things. And if we were to launch our spacecraft and point it towards Uranus, it would take 22 years to reach it. It's got about 19 AU distance to travel. Now, Voyager 2 is the only mission to have flown by, and here are the largest moons. Now, we discovered the first four nearly all at the same time, but it took nearly a century before the last large moon, Miranda, was discovered. It's because it's so far away and it's so small and it's not giving off its own light, these moons. And so they're really, really difficult to find. We've counted 27 moons to date. Okay, So Neptune and Uranus are both ice giants, which means they're made out of cold gases. Now Neptune has a few interesting things going on. Neptune is a giant ball of gas, but the gas is methane, the CH4 molecule. So what does C stand for in CH4? If I tell you CH4, you're like, what is that? C stands for carbon. H stands for hydrogen. Okay. Now, basically, CH4 molecule, methane's basically a giant fart. So but it spins really fast. So the average daily wind speed, no pun intended, is 1,200 miles per hour. So that's 4 times faster than any hurricanes ever get on planet Earth. Now, Neptune also radiates 3 times as much energy as it gets from the sun. Where's that energy coming from? It's coming from the core. Now remember, Neptune has a lot of CH4 running around. That C, it stands for carbon. H stands for hydrogen. What happens to carbon under intense heat and intense pressure? You tell me. What happens? Remember the movie from Superman when he took a piece of carbon and he crushed it in his hand and it turned into grown-ups, parents, turned into a diamond. That's right. So what do you think it rains on? What do you think it rains on Neptune? Diamonds. What does it smell like? Right, exactly. So scientists think there is a hard rain of tiny little diamonds that could be falling into these boiling oceans of liquid methane. Wild place, isn't it? So Voyager 2 is the only mission to have flown by Neptune. So we don't know these things for sure, but it's a guess. And it would take our spaceship 38 years to get there. How old are you now? Yeah, if we started our space journeys, how old would it be in 38, 40 years? It would be a lot older, right? Okay, so what is the definition of a planet? A planet has to do 3 things in order for it to be considered a planet. Okay, it has to orbit the sun, right? So the moon is out. Our moon is not a planet. It orbits the Earth, not the sun. Okay, it has to have cleared its orbit out of smaller objects, or of other objects. And it has to be kind of round. So let's take a look at Pluto. Now, Pluto isn't just one planet. It's a system of 4 objects. Let's take a look. Do you see this picture here of Pluto and Charon? So Pluto is the larger one. They're both orbiting. Charon is not going around Pluto. They're both orbiting a place that's between, here, Pluto, Charon. They're orbiting a place about here. And so they're both going around that point. With the moon and the Earth, so here's the moon, here's the Earth. The moon and the Earth are pointing a spot, are rotating around a spot that's inside the Earth. So the Earth gets yanked on a little bit by the moon, but not enough for it to want to swing around the moon. So the moon is going around a point that's inside the Earth. They're actually going around at both a point where the Earth is just wobbling a little bit. And so that point is inside the planet. So that's what they mean. Now, Pluto and Charon are going around each other. They rotate a point that's between the 2 of them. So that's one thing that doesn't make it a planet. The other thing is scientists found 2 more objects going around Pluto called, around Pluto and Charon called Hydra and Nix. So actually, there's 4 objects gravitationally. So we got Pluto and Charon, then we have Hydra and Nix. And then in 2011, they also found even more. And they found Styx. And here, let me show you different. Okay, so they found even more objects. And then when they zoomed out even more and were able to see even further, they found 700 to 700,000 more objects. So instead of adding all of these objects to the solar system and driving kids crazy with trying to memorize them all, what they decided to do is they said, okay, Pluto's here. We're going to recategorize it since we found out all these other objects. They're actually bigger than Pluto. And instead of adding hundreds and hundreds of more objects to our solar system, let's say that everything beyond Neptune is now called the Kuiper Belt, K-U-I-P-E, or Kuiper Belt. And Pluto is now a member of that Kuiper Belt. So it just got recategorized. That's basically all that happened. And so the 5 dwarf planets in our solar system are the ones that you see here. You can take a screenshot of this if you'd like. Okay, so there's a lot of trans-Neptunian objects, TNOs. Okay, so these are the largest ones. And they're finding more all the time. Okay, so how many suns does our solar system have? It just has 1, right? Okay, so these are all real photographs. This is really not how close they are. We just put them all here so you can see them all. So our solar system has 8 planets that we just talked about. They're moons that we also talked about. one sun at the center, which is actually not that common. It's more common to have more than one, like 2 or 3. And smaller objects such as comets and asteroids, which we are going to talk about tomorrow. But I wanted to teach you how you can actually get meteorites tonight. Okay, so these are the 8. Can you point to the 2 ice giants? Which ones are the ice giants? Yep, we got the 2 on the end, Neptune and Uranus. Okay, which ones are the gas giants? Good. And then we have the 4 here, the terrestrial rocky planets. That's right. Okay. So let's pause here just for a second. How are we doing so far? You guys enjoying this? Okay. So kids, take out your typing fingers, stick them on the keyboard. Tell me what one thing you liked most out of class that maybe you didn't know, or something you thought was super cool. Type it to me right now so I know what you enjoyed most. Can you do that for me? Tell me just what you enjoyed the most. And I am going to show you a couple of experiments you're going to do after class. So type. Tell me the things that you liked most. And it's experiment time. You ready? Okay. So we are going to pause here. I could keep going for 4 hours, and I'm sure some parents out there would love it if I did. So I'm going to give you some resources. Parents, get a pencil. Kids, get a pencil and start to write this down. I'm going to give you a number of resources to continue. I've got 3 or 4 experiments you're going to do right now. We're going to end class, then we're going to come back tomorrow. We're going to continue this talk. We're going to move on to the comets and asteroids of our solar system, and then we're going to move on to black holes. And then we're going to move on to solar astronomy, telescopes, binoculars, and spectrometers, and how to measure the speed of light just using something like a candy bar. So we have a lot to do this week. I just talked about everything we were going to do. That link that I promised you at the beginning is working. Yay! So let me show you how to register for the black hole class. Because the black hole class has like worksheet downloads, it's got a ton of stuff and other additional information you need. You can't do it on Facebook Live. It's just too big of a thing. So you can register for that one. It's free. There's no catch. You just need to register. It'll be at 10 o'clock Pacific, same time as we did this one. It's just not on Facebook Live. Make sense? Okay, so let me show you where these resources are. And then kids, I have some cool science projects we are going to do. You ready? Okay, so resource time. Let me share my screen with you. Here we go. So first resource is Supercharged, here, write this down, science.com/astronomy. Okay, superchargedscience.com/astronomy. And when you pull that up, you'll be taken to a page. All you do is you put in your email, and then I will send you all send you to a page that has all the really cool downloads for you to take advantage of. And it looks like, let's see if I've got it here. Maybe I can't pull it up this fast. Okay, well, I don't have the actual page. So here, I'm going to put in my email address. Here, I'll show you. And my name is Aurora, and you click download now, and you'll be taken to this page here. You have a black hole explorer game, how to tell what's up in the sky tonight, how to do basic stargazing, exploring black holes. There's a printable sky map for you. How to avoid getting ripped off if you want to buy a telescope, and microscopes, the best ones that I recommend, stargazing apps, and my classic version. If you like Monopoly, you're going to love Spaceopoly. You just print out, this is a game I made, and so you can print that out. So all this is on there. So this is at superchargedscience.com/astronomy. Okay, so that's resource number 1. Resource number 2, I put together, so if you like science and you like math and you want to do more than just what we're doing at 10 a.m. During our live classes, I put together a free online school. You don't even have to put your email in, here, let me just show you the whole thing. You just go use it. And so it's superchargedscience.com. It's superchargedschool.com. Supercharged School. You can register. It's free. And then you have all these super cool experiments you can do. You can go to math and science, and you'll see lesson 1, 2, 3. We put science with math because, honestly, math is the language of science. You need to know how to use it and what it's for. Otherwise, kids are going to scratch their head and go, what do I got to learn this for? This makes absolutely no sense. So we put them together so you can actually see what they're for. Now, If your kids still are still younger, it's okay just to not do quite so much. If your kids are older, 4th, 5th, 6th grade and beyond, and they have not memorized their multiplication tables, your next lesson is here, lesson 6, multiplication tables. I show you an easy way where you only have to memorize 3 numbers, and you can easily get your 12 by 12 down, as well as your 20 by 20. Your 20 by 20 will memorize a few more numbers, but all complete instructions for that is here. So if you're struggling with multiplication tables, by all means, take advantage of that one. If you've already got that, it's time to start doing math from left to right instead of right to left. And so all of these experiments are for you. And it's not just math. You see, we've got reading and writing, health, language, art, music. All of these things are on here. Now, when you first go to the page, you'll notice this super cool image. When you click it, that's how you register for the black hole class. You see it? And so that form is working. Yay! And it's on Wednesday. So it's in 1 day, 23 hours from now. And so this is a free class, and when you enter in your name and email, then I will send you the shopping list that you need, which is really easy. It's actually materials you already needed for this week. Okay, so those are free resources for you just to help you guys out, because I know there's a lot of craziness in everybody's lives, so this is supposed to be helpful and friendly and exciting for your kids. Okay, kids, you ready to do your projects? Okay, project number 1, let's see. Okay, project number 1. So you have a piece of paper, right? So can you curl it into like a cone for me? Okay, kind of like that. Make like a cone, like an ice cream cone. You probably have done this before when you're just like fiddling with paper. Once it's in a cone, go ahead and tape it shut. Okay, so what are we doing? We are going to teach your parents why satellites have to stay in orbit and why they move when they're in orbit. If I take this ball and I throw it, eventually it's going to hit the ground, right? So that ball is going to fall 16 feet the first second. If I throw it even faster, it may go further, but it still falls 16 feet the first second because gravity pulls on all objects equally. Okay, so as long as we are on this surface of this planet, any ball I throw, no matter if I'm like the world's best ball thrower, baseball pitcher, there we go, baseball pitcher, 100 miles an hour, it's still gonna fly, it's still gonna drop 16 feet the first second. If I fire this out of a cannon, how many feet is it gonna fall the first second? 16. So it's still gonna, no matter how fast the horizontal is, the vertical is all the same because that's what the pull of gravity is doing, right? So imagine this. Imagine we throw it so fast that the rate that it falls, now if we go fast enough, we're gonna see the Earth start to curve, right? It's gonna, because the Earth is round. What if we throw it at a rate, so the rate that it falls matches the curvature of the Earth? Now that thing is in orbit, right? Any faster, what's going to happen? If satellites go faster, yeah, they get slung into outer space. What if they go too slow? Eventually they crash in on the planet. Okay, so the Earth is down there. It's at the little tip here. And your marble is at the top. And as I'm talking, you're going to try and keep your satellite in orbit around the Earth here. It's kind of a different orbit, but it's going to have the same idea. If you can get this thing... You can use a bead. I'm actually using a bead. If you can get this thing rotating round and round and round and round and round and round and round, it should stay at the same spot. But if you go too fast, it'll go flying out. If you go too slow, it'll just crash back into the bottom here, right? Satellites have to stay in orbit. So satellites that are in orbit, are they moving? Yes or no? The answer is yes. They're moving 5 miles a second. So they can complete one trip around the Earth in about 90 minutes. So the space station goes once around the Earth every 90 minutes. Otherwise, if it goes too fast, we'll never see it again. If it goes too slow, we'll see it again too soon, right? Okay, so that's why satellites stay in orbit. Okay, second thing I want you to get is, okay, a measuring tape. Oh, I know, I think I forgot to put that on the list, but hopefully you have one. Okay, so in the description, I actually show you here. I'm actually going to show you a slide really quick. So in the description, I actually give you the distances from the sun to each one of these planets. Your job is to actually build a scale model solar system. So you can take your measuring tape, you can take some chalk and head outside. If the weather's bad, do it inside. And you can build yourself a scale model. So for example, here is one. This is actually a giant measuring tape. It's about 100 feet long. And I know it's shaped like the sun because the sun will be at the center. But here we have, here, I'll show you, we have Neptune. And so we keep pulling and pulling. So this is a measuring tape that already has the distances already figured out and printed. And so the idea is, as I'm pulling it out, a kid would grab on. Oh, here's Uranus. And so the next kid would grab on. And then we would keep pulling and keep pulling and keep pulling until maybe we'll find Saturn. And now we're going to do, so you can make this with this using the measurements that are in the description for this class. Does that make sense? Okay, so that is your, yeah, now I've got this huge pile on the floor. And we only went to Saturn, right? Should we pull it out more? Let's see. Let's see how far Jupiter is. Oh, there's Jupiter. Okay, now let's see how far Mars is. Okay, oh, wait, no, we have our asteroid belt. And Mars, they forgot to print Mars on this one, so. And this was made by somebody, so. Okay, and here's the Earth. You can see it here, and it feels like it's jammed. It is jammed. Hang on, you can unstew it. Okay, there's Venus. So we got Earth and Venus are really close together, and Mars was there. And I think I can unjam it. There's Mercury. And then that's the sun. So this is a scale of, you see how close these are together? And then look how close these are together. So this will give you guys a sense, or kids a sense of, you know, how far and how much space there is between different things. Okay, so I know we've gone a little bit more than 20 minutes. It's like 45. So for tomorrow, we are going to do comets. I'm going to make a comet for you using chemistry. We're going to freeze some gases. You don't have to make this this project. This is something that I'm going to do. If you want the recipe to make after class, I'll give it to you. That's totally fine. But we're going to make a comet. We're going to talk about objects that are also in our solar system that are not planets and not moons, ones that are coming through our solar system that we kind of never noticed before. There's been 2 or 3 recent discoveries that have been really caught scientists by surprise. So we're going to talk about that. So on Wednesday, just to reiterate, to be clear, so tomorrow's comments, Wednesday, we are going to talk about black holes. And so you can get the, here, you can register here. Go to, let me put this link in the comments so you have it. Black hole class is one you have to register for because it is not on Facebook Live. You simply enter in your name and email and you will get signed up for that. Please do share this with anybody else you think would be fascinated to learn what we know about black holes. I'm going to show you 3 different ways to detect them, what they're about, and what scientists know, and what a lot of stuff we don't know. Thursday and Friday, we're going to do more scientific type measurement type stuff where we are going to measure things and we're going to build spectrometers, and I'm going to show you how you can split the light into its different wavelengths and do some measurements on light itself, which is super cool. You're going to measure the speed of light. You're going to do a lot of fun things. So I hope this has been helpful. I hope you've enjoyed the class. Please tell me in the comments what you like best about this class. Also, tell me what you'd like to study. Because we're doing astronomy because it was the #1 above anything else by a lot last week when I asked, hey, what do you guys want to know? I can prepare stuff for next week. So far, chemistry has come in as a #2. So astronomy was #1, so we're doing astronomy now. If you guys still want chemistry, we'll do that next week. But there might be something else you're interested in learning about, so please do let me know. My name's Aurora with Supercharged Science. We are providing free science classes in both science and math, and actually more. If you go to Supercharged School, you will find all of our cool science experiments that that you can, not just science, but there's reading. I have my book challenge out for kids, 300 books that I personally have read to my kids that are amazing, as well as the beginning readers are in here. You can look at that. The writing assignments where kids actually win prizes is in here. Wow, that's like the same kid, isn't it? I didn't even notice that. And then we have a whole bunch of stuff in health, like how to make a robotic hand, what's your lung capacity. There's a lot of cool projects in here, nutrition for kids, and how to keep your exercise going. We also have language, and we have art, and we have music. And we have, these are some musical instruments you can make so your parents look like that. No, I'm just kidding. If you are interested in doing family game night, these are 50 of the family games that I personally do with my kids, including complete instructions on how to make your own escape room. The next class you can register for by clicking here. This is going to lead you to the astronomy and black holes. And if you are interested in any of our online curriculum that we provide, you can certainly check that out as well by clicking on the whole shebang. So I hope this has been helpful. If you like this, please share it with as many people as you know that need help during this time. This is a free service we're providing. I will see you guys next time. If you have questions, you can always email me, aurora@superchargedscience.com, and I will see you tomorrow. Take care, everybody.